Hi folks, it's Mr. Williams. The topic right now is finding y values when we're doing limits, finding them from graphs specifically. If you ever go into calculus, you will do this with equations, but we're actually just doing this with graphs right now. So make sure that you watch the last video before this over the notation for limits. So right here we are using the graphs that are on Google Classroom. You hopefully can see that on the x-axis on this first one I'm counting by 2s, on the y-axis I'm counting by 1s. On the one on the right, I'm counting by 1s, both left, right, up, and down. So on this one, we've got the left-hand limit as x approaches -4. Left-hand limit means that you start on the left. X approaches -4 means that you are going toward the x value of -4. We can go ahead and write our form down. The limit of f of x, we know this is f of x because it was labeled. We've got the equal sign. We've got x approaches -4. We are told that this is left hand, so I'm going to put a little minus right here. Now we need to find out what the y value actually is for this. Remember, left hand means you start on the left side. X approaches -4 means you go toward an x value of -4 and say, what is the y value getting closer to there? So we are going to start on the left-hand side of this function, and we are going to trace it starting on the left until we get close to an x value of -4. Right close to this x value, you can see that the y value is getting closer and closer and closer to 1. Same idea for this next one. The right-hand limit means you start on the right-hand side. X approaches -4 means you go toward an x value of -4. We're going to write this form in a similar way. Limit f of x equals, we've got x approaches -4. I'm going to put a little plus here after it, small and high, for right hand. And now we're going to find this. This y value. One thing that I do need to mention is that on this is a piecewise function, which I mentioned, I believe, in the domain video. A piecewise function is a function with multiple pieces. So this curve and this line are all part of the same function. They are all combined to make f of x. So right hand is start on the right hand side, approaches -4 is go toward an x value of -4. I'm going to start on the far right of the function. I'm going to go toward an x value of -4. Right here, it skips over here, that's fine. And as I trace this, the closer I get toward an x value of -4, the closer that y value gets to here, that is 5. Now, this is not asking what is the value of the function at x equals -4. That is determined by this dot right here. The value of the function at -4, f of -4 equals 1. That's not what we're wondering. What we're wondering is what is the function like around -4, specifically to the immediate left of -4 and to the immediate right of -4. Last one for this particular graph, the limit as x approaches 8. I'm going to set that up. Limit of f of x. X approaches 8. One thing that you hopefully noticed is that I did not say left hand or right hand on this one. The reason why is because if we look, if you start on the left and go toward an x value of 8, you get close to here. If you start on the right and go toward an x value of 8, you get close to the same thing. If the left-hand limit and the right-hand limit are the same, you do not have to specify whether it's left hand or right hand, and that y value is -5. So, again, this one is pronounced the left-hand limit of f of x as x approaches -4 equals 1. The right-hand limit of f of x as x approaches -4 equals 5. The limit of f of x as x approaches 8 equals -5. And yes, I know that it's not red from left to right like most stuff is, but it's just kind of the way it is. On this right-hand graph, we have the right-hand limit as x approaches 1. So right hand means that we start on the right-hand side. X approaches 1 means that we go toward an x value of 1. I'm going to label this as g of x. And I'm going to go ahead and start with my notation. So I've got the right-hand limit of g of x as x approaches 1 equals. I'm going to find out what that is. Right hand means that I start on the right-hand side of the graph. I'm approaching or going toward an x value of 1. And the closer I get to an x value of 1, the higher up that goes. It never actually reaches 1. But as I'm getting close to 1, when I start on the right-hand side, it goes up and up and up toward infinity. Reminder of what I mentioned in another video, that this is called an asymptote, and that we'll go into more detail about those later in the year. Left-hand limit as x approaches 1. We already did right hand, now we're doing left hand. I'm going to go ahead and write my notation. The left-handed limit of g of x as x approaches 1 equals. We're going to see what it is. Left-hand limit means we start on the left-hand side. We are going to trace this and get closer and closer and closer to positive 1. And the closer we get to 1, the farther down that goes. Down is a negative direction, and it goes toward negative infinity because it goes down forever. Now again, this is not saying that this is what it is at x equals 1. At x equals 1, there's an asymptote. The graph does not exist. But as you get closer to positive 1 on the left-hand side, it goes down toward negative infinity. And as you get closer to positive 1 on the right-hand side, it goes up toward positive infinity. One more example. I'm going to label our x-axis as 1s, and our y-axis I'm labeling by 1/2. Okay. So I'm going to do actually 2 on this. I'm going to do right hand limit as x approaches 1, and then I'm going to do the limit as x approaches infinity. So we have right hand, so we're starting on the right hand side of the graph. X is approaching 1, so we are going toward an x value of 1. I'm going to label this h of x. I'm going to start off my notation. We've got the limits, LIM for limit, h of x equals sign, x approaches 1. This is going to be right hand, so I've got that little plus right there. The right-handed limit of h of x as x approaches 1 equals. So right hand is saying we're going to start on the right. We are approaching 1, so we are going toward an x value of 1. And the closer we get to an x value of 1, the closer that y value gets to this, an x value of negative 1/2. And then the limit of h of x as x approaches infinity. You will notice that I did not put left hand or right hand on this. The reason why is x approaches infinity means that it goes to the right forever. If it's going to the right forever, the only direction that you can start from is the left, so we don't have to say left-handed. If you want to put a little minus there for left-handed, just to be consistent, you can, but you're not required to. And the technical notation is that it doesn't have that. So x approaches positive infinity. Remember, x positive infinity is right forever. As this goes right forever, it is also going down forever. So as the x value is going to the right, that's a positive direction, forever, that's infinity. The y value is going down, that's a negative direction, forever, which is infinity. So that is limits. Email me if you have any questions or ask them in Google Classroom. Until next time, be well, do good.